Today on the Energy Podcast.
It's the glue in the concrete, and concrete is the mostly used building material in the world.
They use a lot of energy to produce cement, and the use and the choice of energy need to change over time. In total, the sector emits between 2.4 and 2.8 billion tons of CO2.
The first customers really are the ones who have those volume of or emission of CO2 which are hard to abate, with industries such as steel, cement, waste incineration, because those are very much needed in the future.
In this series, you'll hear about the challenges of decarbonising industries that impact all aspects of our life: cement, steel, and everyday products. Where energy comes from, its reliability and its affordability is one of the biggest issues facing society right now. And energy takes centre stage at the Global Government Climate Conference, COP27, as it plays a critical role in reducing carbon emissions. In this series, we will be exploring how we can cut carbon from the big industries that produce the building blocks of modern living, from the clothes we wear to the cars we drive and even the bridges we drive over, and how this can help limit global warming to 1.5 degrees as laid out in the UN Paris Agreement. Today we'll be focusing on cement, the main ingredient in concrete. From bridges and canals to homes and offices, cement and concrete are all around us. Many famous Hollywood stars have even put their handprints in it. But the cement industry emits up to 7% of all carbon dioxide emissions globally each year. So how can that change for the better? Hello, I'm Julia Streets, and on today's episode of the Energy Podcast, 1.5 and cement. In a moment, you'll hear from Kristin Myskja, Director General of the Climate, Industry and Technology Department at the Norwegian Ministry of Petroleum and Energy, and an expert in collaboration. And joining us is Audny van Helden, Shell's Vice President of Sectors and Decarbonisation, who is no stranger to big industry. But first, we're off to Norway to find out how cement is made, and more importantly, what is being done to reduce carbon emissions created in making it. Northern Lights is a partnership between Shell, Equinor and Total Energies and combines a specially designed ship with carbon capture and storage technology to help one cement producer lower its emissions. Heidelberg Cement in Brevik in Norway produces about 1.3 million tonnes of cement every year. Judith Durkin has been to visit the plant and to speak to Per Brevik, their Director of Alternative Fuels.
Perhaps unsurprisingly, Heidelberg Cement's Norcem plant in Brevik in the southeast of Norway is made of concrete, the most important ingredient of which is cement. This plant is nestled in a little valley on Norway's coastline, and to my left is the plant's deep harbour, which can accommodate the loading and unloading of huge shipping vessels.
This is a really old plant. We have produced cement for more than 100 years here. When you are producing cement, you start with limestone. Most cement plants, they are located close to limestone sources. And then the limestone is quarried. We do it as carefully as we can. Then it's through mills to make it like a powder, which we call raw meal. This raw meal is put into the kiln and is heated. And then when you reach 900 degrees C, the meal is split into calcium oxide, which we need for the cement production, and CO2. And the problem for the cement industry is that this is the only way that you can produce cement in big volumes.
And why is cement so important?
Because it's the glue in the concrete, and concrete is the mostly used building material in the world.
So what made you decide to go down the route of using carbon capture and storage to help decarbonise the plant?
The splitting, what we call the calcination, is unavoidable, and that's 2/3 of the emissions from our plant. Therefore, it's important, okay, we have to do something with the flue gas coming out of the chimney, capture it, clean it, condition it, and then it's taken to an intermediate storage here, pumped into ships, and then the ship brings it from Brevik around the Norwegian coast to the western part of Norway before they permanently store it in the North Sea.
So I see that we're standing right next to the harbour at the moment, so this is a pretty well-located cement plant to be using the Northern Lights project.
It's perfect, and that's one of the big advantages. And most of the cement produced here, more than 90%, is going out by ships around the Norwegian coast.
So from this harbour we'll see cement leaving and CO2 leaving?
Yes, we will.
I've now followed the coast of Norway north, and I've reached Øygarden near Bergen, which is where the Northern Lights CO2 transport and storage project is based. CO2 from Heidelberg cement will ultimately be brought to this site, where it will then be transported by pipeline to be safely and permanently stored deep under the seabed of the North Sea. Like Heidelberg cement, it's situated on the coast, and at the moment I'm standing on the harbour where ships will come in full of CO2 ready to be taken away and stored under the sea. And off to my left is the site where some huge CO2 storage tanks will ultimately go. To learn more about this project, I had a chat with the project's technical director, Kristin Myskja.
So when the CO2 is delivered from the ship to the quay, it's being offloaded through some loading arms and run through the piping that we will install shortly and stored in the temporary storage tanks to be able to offload quickly the ship so the ship can go and pick up some more CO2. And from those storage tanks, it will be piped through a pumping system and then injected in our pipeline to be then being transported all the way to our offshore storage site, 100 kilometers through the pipeline, and injected 2.6 kilometers below the seabed into our well for storage, permanently stored. So on the first phase of Northern Light, we can store up to 1.5 million tonnes of CO2 per year. But then later on, we are actually also developing the phase 2 of the project.
And where will that CO2 be coming from?
So this CO2 will come from various industries. The first customers really are the ones who have those volume of or emission of CO2 which are hard to abate, with industries such as steel, cement, waste incineration, because those are very much needed in the future, and that's the process itself which emit the CO2.
And is it useful that you've got sort of these deep fjords? Is Norway an ideal location for CCS?
Well, Norway is an ideal location of CCS, not so much because of the fjord, but more because we have so much storage capacity. All the fields which have been exploited can be turning into potential storage. Not all of them are perfectly suitable, so there's a lot of analysis and study which needs to be done, but there's also a lot of underground aquifer, so water type reservoir under the seabed. And those also are very good storage. So there's a very, very large capacity on the North Sea.
And how can you ensure that the CO2 actually stays down?
So this is a very important question, actually, because what we know is that there's 4 mechanisms which actually trap the CO2 in the reservoir, in the saline aquifer. And those mechanisms are very well known to energy companies like we have, because they are the same mechanism which actually hold oil and gas in place for millions of years. In addition, we have a lot of requirement to monitor that CO2. We do some seismic surveys and monitoring to follow what we call the plume, which is the dispersion of the CO2 underground. So we know exactly where it is, how fast it moves, where it goes, and where it's permanently staying eventually.
What would you say to skeptics who say that CCS is just an excuse for oil and gas companies to keep drilling?
Well, the thing is, CCS is not the solution for mitigating the climate change, right? But it's one of them, because once you've transferred all your energy supply to renewable, as much as you can, some process still emits CO2.
So we'll need Northern Lights plus many, many more.
We need thousands of Northern Lights, and we need them as fast as possible. So we're not competing with each other, all the different projects. We actually should really help each other and try to help other people to participate into the rollout of CCS.
Our thanks to Kristin Myskja, and before that, Per Breivik. And if you want to find out more, go to our episode page where you can find out further information about the Northern Lights project. So allow me to reintroduce my guests. Kristin Myskja and Audny van Helden, very, very warm welcome to you both. It's great to have you on the show. So we were talking in that segment about how important it is to address emissions from industries like cement. And Audny, I'd love to come to you first of all, just to hear your thoughts about why this is so important.
The cement industry, as you just already pointed out, Julia, is one of the what we call hard-to-abate sectors, right? They emit about 7% of the total CO2 emissions in the globe. And if you are not going after this segment, we will not be able to achieve 1.5 degrees Paris climate agreement. So it's a sector that is in itself so large that we need to help it to decarbonize. And that's exactly what we are doing. They use a lot of energy to produce cement, and the use and the choice of energy need to change over time. But even if they would change all of the fuel that they use today to create cement, they will still also ultimately emit CO2, because about more than half of the total emissions come from the process of making the cement itself. In total, the sector emits between 2.4 and 2.8 billion tons of CO2. And about 60% is from the chemical process of producing the cement, and 40% is because of the fuels they burn, whether this is gas or coal. Very often it's still on coal, which they need to create the heat to convert the limestone into cement. So it's a sector that needs help to decarbonize, and it needs new technology and innovation in order to also contribute to a cleaner and a lower emission world.
And Kristin, I wonder if I could bring you in here, because I'm really curious about a couple of projects you're working on, and also the role of technology as well. Talk to us about what you're doing.
So what we've done in Norway, and I'm with the Ministry of Petroleum and Energy, so this is sort of the governmental perspective to this. We've stored CO2 on the Norwegian continental shelf for 25 years in relation to gas extraction from the Sleipner field and also later on the Snøhvit field. And we saw that we could build on the competence that we have in our oil and gas industry to really make a difference on a global scale and to try to reduce emissions from these hard-to-abate sectors. So 2 years ago, the Norwegian Parliament supported a financing package for what we call the Longship project. You've discussed with Per Breivik earlier on, and also the Northern Lights project is a part of this Longship project. In addition, we have CO2 capture at the waste incineration facility here in Oslo. And the project is being constructed as we speak, and it includes capture at the cement plant, waste incineration facility, and then offshore subsea storage 2,600 meters below the seabed in the North Sea. And so by enabling this project, we see that we can make a difference in sort of getting CCS off the ground, and proves to the world that it is possible to do carbon capture and storage to lower the cost. And hopefully this project will disseminate the technology further on to the rest of the world. So what we see is that carbon capture and storage and CCS needs to play a role in the long term. And we see that by enabling this project from the Norwegian state side, we can actually provide technology development and cost reductions for several projects that comes after. So the state's role in this is to provide state aid and to act as a sort of risk-bearing cushion between the capture side and the storage side. But it is the industrial actors that are actually building the project and developing the technology.
What do you see the future of CCS?
Well, what we've seen is we see signs that the Longship project, which Northern Light is a part of, is becoming the market enabler that we really hoped for when we did the investment decision. We see increased interest for new CO2 storage acreage on the Norwegian continental shelf, and we have already dealt out 2 licenses for other CO2 storage projects. And we also see increased interest from European industry to actually come with their CO2 and store it in the Northern Lights and on the continental shelf. So that's really interesting, and it's a very good development and what we really hope for. One of the most important aims for this project was for it to be a market enabler, and we really hope that other countries will also follow suit and develop CO2 capture and storage projects in their own countries. We are more than happy to help with our knowledge on the technology side, on the regulatory side, and to provide with all the competencies that we have. So we really do hope that other countries will follow.
And Audny, can I come to you? I'm really curious to know, what is Shell's role in all of this specifically?
Thanks, Julia. I see Shell's role in sort of 3 steps. I see that we are a supplier of energy. If you look at the energy that is being used creating cement, there actually is 1 megawatt hour per ton of cement required. So there's a lot of electricity as well. And on top of that, you need gas or coal. By providing cleaner energy to this industry, we can help them to decarbonize. So I see our role first as a supplier of cleaner energy. Then second is also that we see ourselves as a collaborator, right? So I think it's clear that in order to decarbonize industries, you really need to work together in the value chain. Not only the companies that need to work together in the value chain, but you also need important stakeholders like governments. And research institute, technology developers, maybe academics as well. And governments in particular play an important role because they set regulations, they can help create a market, create demand, and they can also influence, for instance, how tenders are being set. And this is something I want to mention specifically because that gets me to our third role. We are also a buyer of cement. So think of our renewable projects where we invest in offshore wind parks. That is also where we need to do the foundations of cement.
So I wonder if we could just explore some of the driving trends that are also affecting the pace of change. So, for example, right now we're in the middle of an energy crisis. And Kristin, I'd love to get your thoughts about, what impact is this having on developments?
Well, obviously, security of supply dominates in the short run. But what we see, and from our perspective, industry and governments in Europe are not derailed on their ambitions for the green transition. So in a way, we see that this current energy crisis has a sort of short-term solution. And then the medium and long-term solutions, they're still as strong. So we need the Repower EU plan underlines the commitment to the transition through diversifying energy supply, energy efficiency and accelerating clean energy. And part of the medium-term plan is to accelerate the development of a hydrogen market. And I believe CCS and blue hydrogen, which is sort of hydrogen made from gas, but with CCS, so you have low CO2 emissions in the production of that, plays an important role in scaling up this infrastructure.
And it's fascinating to sort of hear you think about some of the short-term drivers, but I wonder if we could just look a little bit further out, because one of the conversations that's taking place is about the trends towards urbanization of populations. We think that by 2050, this is going to rise to almost 70%, which is more construction, more homes, more schools, more airports as well. And Audny, I'd love to hear your thoughts about, what do we need to think about given that long-term trend?
I think it's clear that the trend of urbanization in the globe is happening and is real and is not going to go away. Energy crisis doesn't make any change to these sort of macro level global trends. And that means the demand for cement and for concrete is only going to increase over time. Especially if we look at the east, where we have large metropolis cities growing and growing, the demand for concrete and for cement is only going to increase. And so far, we don't have better alternative building material available. And that means that we do need to look at how can we decarbonize the cement industry in a serious way. And again, CCS is one of the key solutions that we need here.
Kristin, I wonder whether I could ask you a final question, if you would, which is, if there were one single thing that you believe would make the biggest difference in overcoming this challenge and to help the world stay on track to 1.5, what would that be?
I believe there is no single thing that will make the biggest difference. And too often we look at different technologies in isolation and see, so it becomes a question of either or, but I believe we need an array of technologies to work together to solve this puzzle. We need as much renewable energy as we can possibly provide. We need CCS in the hard-to-abate sectors. Hydrogen could play a role in all this. Energy efficiency is, of course, very important, but I think there are no silver bullets. So we need great engineers. We need policy and markets to work together to achieve energy security and a fair transition, which is also important. So I think we all have different roles to fill and we need all hands on deck.
Well, thank you both very much for your time. Audny, it's been a joy to have you on the show. Thank you.
Thank you very much. I really enjoyed it.
And Kristin, thank you so much for your time.
Thanks for having me.
So it's been a fantastic conversation because in a really short period of time, not only have we talked about the decarbonisation of cement, and it's clearly hard. And within that, we've unpicked the role of government, the role of industry. We've explored what Shell is doing around that, but also we've thought about it in terms of decarbonisation, supply chains, collaboration, and all against a backdrop of change. Short-term change in terms of the energy crisis, and long-term trends in that the global population is moving towards urbanisation. So my thanks to Kristin Myskja and Audny van Helden for all your thoughts, and of course to Per Breivik and Christel Lupton. You've been listening to the Energy Podcast brought to you by Shell. So listen and follow for free wherever you get your podcasts so you don't miss an episode. And next time,
being able to shift big industry in this capacity requires massive infrastructure changes. It requires both a construction and timing as well as a monetary incentive.
our focus turns to the steel industry. The Energy Podcast is a Fresh Air production, and I must remind you that the views you've heard today from individuals not affiliated with Shell are their own and not Shell plc or its affiliates. I'm Julia Street. Thank you for listening, and until next time, goodbye.